People have asked me, what else is new? What are some new deadly misconfigs? And I've been waiting for an opportunity to update, and finally this is my chance. So I'm really excited that there have been a number of really great Yarn talks. I hope all of you have been to those Yarn talks. I went to a really good one this morning from Mayank from eBay, where he talked about how they deployed Yarn on a 400-node cluster. And from my 3 years of supporting pretty diverse clusters, so we're talking about clusters ranging from 10 nodes to hundreds of nodes, to 500 node, 600 node clusters, this is where you're going to see a lot of the issues, because you're not going to see the same issues running the same workflow. You're going to see a lot of different issues when you run a diverse workflow, when we have several services running at the same time. And these are the kinds of issues we face here at Cloudera, especially at Cloudera Support, where I started as the first support engineer at Cloudera. Since then, I moved into more of a field role, so I currently manage our 2 largest customers. And it's really exciting to watch the different workflows they have, the different use cases they have, and figure out how does Hadoop map to what they're doing. And for me, the first and foremost step is to figure out what are they trying to do, and then figure out the right technology, whether it be in the Cloudera stack or not, right? At the end of the day, I'm their technical conscience. And a lot of what I've put into this presentation is what I've learned firsthand from supporting these customers. I'm also a Scoop committer, so I have a couple of free copies. If you didn't pick one up, we had some book signings yesterday and today at the break. So I will be passing out some books for those who ask good questions. Questions are definitely welcome. I really want this to be an interactive session. And if there's anything that is unclear, something you want to delve into more, feel free to ask throughout the presentation. If it's something that I'll cover at a later slide, I'll let you know, and we'll defer it to then. Otherwise, we can just have a discussion right here. I've given this presentation a number of times, and some of my favorite times were when the audience participated. I don't claim to know all the answers. I've definitely seen a lot of issues, but all of you together, we all have cumulatively years of Hadoop experience, and let's crowdsource some of that. Yesterday, we released C5, and C5 is our first release where we are unifying both CM, which is Cloudera Manager, CM5, and CDH5, which is Cloudera's distributed Hadoop. And it's a really exciting time because it coincides really nicely with all the talks we've had so far at Hadoop Summit, this conference, about Yarn, because C5 is when we are shipping Yarn for the first time as production ready. And within CDH5, it's not just MapReduce and Yarn, but it's all of these. And this is what makes the Cloudera stack. And we'll talk more in detail about some of the issues that we see commonly, some of the more deadly issues that we see. But as you can see from this stack, the reason a lot of the misconfigs we talk about, or rather the MapReduce misconfigs, are because everything depends on MapReduce. So if you look at the amount of time and the number of tickets that we spend most of our time on within Cloudera support, it's MapReduce. And that's because when you run a Scoop job, when you run a Hive job, a Pig job, what it is at its core is it's spawning in the background a MapReduce job on your behalf. So even if you are running a Hive job, you actually really are running a MapReduce job. And if you have any misconfigs with MapReduce, you're going to see it on your Hive job. And we'll talk about a couple examples. Also, what we've noticed, what we've analyzed with these tickets over the past 3 years is that the first overt symptom is a very poor predictor of the root cause. Often you'll see a symptom which, unless you've seen it before, it's not going to be intuitive as to what the root cause is. And again, this is why I'm really excited to see a large crowd here, because that's a smart thing to do. The smart thing to do is to get your configs right the first time. You don't want to spend time diagnosing a misconfig, because it's really hard. It's hard to figure it out. You'll just be spinning your cycles. Mayank in today's eBay talk talked about how he spent days trying to debug these Uber jars in his yarn class path. And it makes sense, right? Because that's not what you think about when things go wrong. You don't think about debugging things in your class path. So same thing with misconfigs. You often don't think, well, I made that tweak months ago. You don't think it's going to have such an impact on your system. But indeed, often these issues, they don't surface until you start running a heavy workload. So you run your Pi jobs, your word count jobs, and everything's fine. And then you start adding load, and that's when you start seeing things. But you made these config tweaks months ago, so you don't draw that correlation. So what are misconfigs? Misconfigs are anything that requires a change to not just a Hadoop config file, so core site, yarn site, MapReduce site, etc., but also to the OS files as well. So we see issues where you need to tweak the U limit, you need to tweak the number of file handlers. Hadoop is a pretty resource-intensive framework, and accordingly, the defaults that come with your OS often do not suffice, and we'll talk about some of those issues as well. As you can see from this graph as well, most of the support tickets, when we did a root cause analysis, we traced it to finally as a root cause to be a misconfig. There will always be bugs, but it seems that with Hadoop at least, it's a system that is pretty rife with misconfigs. I think namely because there are so many config files to begin with. You've got your core site, your yarn site, your MapReduce site, and then when you start running hydras, you've got your Hive site, you've got your scoop site, etc. But even more so is often when you tweak one config, you don't realize it's dependent on another config. And so if you don't tweak that other config in parallel, you're going to start hitting issues. And again, you'll start thinking, well, I already tweaked that config. But often it's hard to realize the relationship between all of these configuration parameters. Word count is the hello world of Hadoop. This is the job that people run when they first start up Hadoop. Also, when they do an upgrade, when they do a new install, they run word count as a sanity check. And often people think, well, it passed word count, therefore all is well. And nothing could be further from the truth, because word count is not meant to put any load on your system. Again, it's a sanity check. And so just because it passes word count doesn't mean that you're certified as misconfig free. There could definitely still be a lot of misconfigs lurking around. And I think the reason there are a lot of misconfigs lurking around is often the defaults that come out of box are misconfigs themselves. So the purpose of this talk is to talk more about some of the issues you encounter. So I'm assuming that most of you are currently running Hadoop. And so can I get a show of hands? How many of you are currently using Hadoop, whether on a small node cluster? Okay, great. Wow. Well, I think I'm preaching to the choir here. So I'm not really going to talk about the fundamentals of MapReduce. Given how many of you are running MapReduce already, I'm sure a lot of you are running in production. I don't want to be going over anything you already know pretty well. But we will use this diagram later, so let me just give a very quick overview of this. As you can see from the left-hand side, you have a text file there with a number of cities. These are cities in the state of Oregon, Portland, Beaverton, etc. And what MapReduce does is it parses this file into key value pairs, sorts like-minded together, and then starts combining like-minded together. And then in this example, in the reduce phase, it does a summation and counts up the number of Eugenes you have, the number of Portlands you have, et cetera, and then combines them finally, and then counts the number, the frequency of each city in your text file. So before we go into the first deadly misconfig, I wanted to take a little bit of time and talk about the architecture behind MR2. Each of the misconfigs I talk about, there is a parallel between what you see in MapReduce 1, what you see in MapReduce 2. So a lot of the issues we see in MapReduce 2, we saw in MapReduce 1 as well, but we definitely need to go about solving it in a different way. So just to define a few terms that I'll be using throughout the presentation. For those of you familiar with MapReduce 1, which I'm assuming with all of the hands raised, that's the entire room, which is great. So MapReduce 1 had one job tracker, also known as a single point of failure, right? If your job tracker goes down, if you don't have job tracker HA enabled, you do have a single point of failure, and also a bit of a bottleneck on it, right? A lot of scalability issues. A lot of our customers start seeing issues when they start running 2,000, 3,000, 4,000 nodes. You start running into scalability issues with your job tracker. So with MR2, they split the job tracker's resource management into a couple of different components. So you have the resource manager, and you have the application master. And so by splitting the functionality, you make the job tracker a lot more scalable, and also less memory intensive as well. For the purpose of this presentation, I'm interchangeably using MR2 and Yarn, but the strict definition is that they're not the same. Currently, they pretty much are. There's only one other application written for Yarn besides MR2, which is the distributed shell, which isn't really used all that much. But for all intents and purposes, MR2 is just an application that you can run on Yarn. And the beauty of Yarn is that you're no longer constrained to running just MapReduce. You can start running things that don't have a MapReduce model, such as Storm, Impala, Spark, Shark, etc. You can run that on your Yarn cluster in parallel, right? You're no longer constrained by some of the resource constraints that we saw with MR1. So in MR2, the resource manager replaces the job tracker, and the node manager replaces the task trackers. And so we'll talk about in more detail some of the issues we see because of this split. So as I mentioned, you start running into scalability issues when you start approaching 5,000 nodes on MR1. When you start approaching 40,000 tasks, you start running into job tracker scalability issues. And another reason you start running into these scalability issues is because you aren't able with MR1 to fully utilize your cluster. And the reason behind that is because with the MR1 slot model, you have very hard partitions between mappers and reducers. So even if you had some free mappers laying around, you couldn't. The reducers couldn't take advantage of that. With MR2, there is no concept of a slot mentality. So you don't have these mappers and these reducers. Instead, you have this common pool of resources of CPU and memory that the Yarn model is then, the resource manager is tasked with figuring out how to divvy that up and to allocate accordingly. Also with MR2, you also have the ability to have faster job completion through what is known as an Uber application master. And that's where you're running everything within one self-contained JVM. And if you're able to run everything within one JVM, you're definitely going to see a lot less overhead as a result. So on to the first deadly misconfig, out-of-memory errors. This is something that we saw pretty commonly in MR1, and this is something that we'll still see in MR2, but you'll definitely want to go about solving it in different ways. I've seen these out-of-memory errors where what happened was that the Hive job was failing. I remember this was a P1, a high-priority support case I worked one weekend a year ago, where we had just succeeded in convincing one of our customers to upgrade to the latest and greatest CDH4 bits. And of course, customers don't like upgrading, right? Everything's working fine. They don't want to introduce risk, which makes sense. But we told them, no, you should upgrade to CH4. It's going to be so much better. And of course, as soon as they upgrade, what would happen, right? All their Hive jobs stop working. And this is on their production cluster, and people are understandably very upset. And of course, they all blame the upgrade. They say, like, look, these Hive jobs were running fine before we upgraded CH4, and then like you told us to, and like now what happened? And what happened was when they upgraded to CH4, they figured, well, why don't we just add more heap size? While we're taking downtime anyway to do the upgrade, we might as well just add more heap size. And they did, but what they had neglected to do was they neglected to tweak the child heap size accordingly and the U limit accordingly. And so for MR1, what we recommend is your U limit should be roughly, which is the virtual memory limit, should be roughly 2 times the size of your child heap size. And when it's not, you're going to start seeing shuffle errors. And in this case, the shuffle errors were so bad that the Hive jobs were completely not finishing, were not coming to completion. And we were able to diagnose that through just a lot of brute force. I ended up just taking a successful job XML and comparing it with a failed job XML and just trial and error, process of elimination, figuring out what parameters changed. And lo and behold, the child heap size had changed and hadn't taken into consideration the increase in heap that had been provided. And that's completely non-intuitive, right? No one would think my Hive jobs are failing because I didn't tweak the child heap size because I added more heap. It's something, added more RAM rather. It's not something that you would immediately think about unless you've seen it before. And now that I've seen it before, when I've seen subsequent, similar issues, right? When a customer has recently upgraded and they start running out of memory errors, I know where to go. Just because I've seen it before. The good news with MR2 is that a lot of the manual tweaking that we did is no longer needed. So for instance, in MR2, there's no concept of a U limit. That's been replaced by the virtual memory to physical memory ratio. And so with Yarn, the memory allocation is so much more finer grained. And so it's got a different set of parameters to tweak as a result. Cloudera engineer Tal Lipkin said it best. I can't say any better than him. He tweeted this. This was a couple years ago when we were all running MR1 exclusively. And it's very true. I've seen customers where they start running into out-of-memory errors, and the first thing they do is they start adding more heap. And then they add more heap and more heap, first to the data nodes, and then to the chat trackers, and then they're running HBase to the region servers. And then before you know it, they've exceeded their physical RAM. It's just something to keep in mind. It's definitely common sense, but we've seen it definitely more than once. So just as a task tracker can run out of memory, the job tracker can run out of memory as well. And in this case, I think you have to go back to how Hadoop was first developed. Hadoop was first developed with the notion that one person would run the Hadoop jobs for everyone. So for instance, if we were all a company here, and if I were the Hadoop admin, I would be running jobs for all of you. And so it would make sense to keep, say, 100 jobs in history in case I need to debug one of your jobs later. Now, with everyone having their own user ID on the Hadoop cluster, it doesn't make sense that you would have 100 jobs that you would need to always keep in memory. So we've noticed that people start running out of memory on the job tracker if they keep their defaults. The default out of the box is to keep 100 jobs in memory. So what we recommend is to, instead of including so many jobs in memory, to include only 5. And that's one of the config settings that we've tweaked, one of the defaults we've reset, so to speak, in Cloudera Manager, which is used for installing and configuring your Hadoop cluster. And so the jobs that you're not keeping in memory, they're not deleted. You can still refer back to them. They're just archived as well. So going forward with MR2, the Uber application masters I mentioned earlier, they allow you to run everything in a single JVM, requiring a lot less overhead, and therefore you no longer have that restriction. You're not restricted on your memory as much. You no longer have to keep only 5 jobs in memory. You're definitely open to, or have the ability to keep more in memory. Fetch failures. So this is the third deadly misconfig. This is something that I've seen in probably every release of Hadoop, starting from when I first joined 3 years ago. I kept thinking that with each subsequent version, we would finally get rid of fetch failures once and for all, but we never have. And it's largely because fetch failures are not just due to misconfigs. They're also due to network issues. They could also be due to hardware issues. There are some known issues with the Jetty server. In MR2, we use a Netty server, which gives you more connections to begin with. So it's less likely to see fetch failures in MR2. But fetch failures still occur. And what they are, as you see in this green box, this is the same word count example we showed earlier, where with fetch failures, you're having trouble fetching, the reducers rather are having trouble fetching the map output. And that breakdown is probably due to not having enough threads, not having enough connections, due to various misconfigurations. In MR1, you're going to see it show up as a fairly innocuous-looking info message, but this is something that, if left untreated, can easily become a fatal. I think often people think, it's an info, nothing to be concerned about. One of our customers started seeing fetch failures on one node, and then it progressed to the next node, and before you knew it, his entire cluster was rendered useless, and that was because this one node hit fetch failures and was not able to complete its jobs. And so all of its jobs got moved over to the next node. And so this poor node, had to not only run all of its jobs, but all of the other jobs as well, which caused a significant delay, a delay of 12 hours. And so these jobs are getting delayed by 12 hours, and you've got the thundering herd mentality where each node's jobs are getting delayed 12 hours at a time. And you can see how that can easily turn into your cluster effectively being rendered useless, even though it's just an info message. There are a number of configs that we recommend tweaking in MR1. Again, these are configs that the defaults out of the box in Apache Hadoop are almost prone to fetch failures. So you do need to tweak them immediately so you don't start seeing this. This is something that we've addressed in Cloud Era Manager as well. And I get that question a lot. Have these things been fixed? They have been fixed in Cloud Era Manager. A lot of these settings, some of them are OS settings, so we can't go about changing those on our users' boxes. But we do recommend in Cloud Era Manager the appropriate setting changes. As I mentioned with MR2, it uses the Netty server instead of the Jetty server. So you're getting twice as many threads as there are processors, and so you're less likely to see fetch failures. But if you do start seeing them, it would be good to make sure that you have configured the shuffle handler configs appropriately. On to federation. Federation is what I would say is something that there's definitely a use case for, but I think it's one of those things where people are more inclined to think they need it than rather really need it. Federation is used for spreading the file system metadata across several name nodes. So you're just basically spreading your namespaces across. So you have multiple namespaces, but you're viewing it as one namespace. So it's used for those clusters that have over 1,000 nodes, and you want to be able to scale out. Often people think they need federation when their jobs start running slowly. We have one customer who their Hive jobs started running really slowly, and they decided that the answer to their problems was federation. And it could be. The short-term solution would definitely be federation, but it would just be masking the problem and not really figuring out what is the root cause. And to really figure out the root cause, you have to take a step back, and you need to start profiling your jobs and figuring out, okay, if my jobs are running slow, where are they running slow? Are they running slow at the beginning? Where is the bottleneck going? Are there network issues? What is the latency caused by? And so that's what we're doing with this customer actually right now. And we're walking them through. We're building a workload profile and figuring out what is the max, the min, the average standard deviations of all of their jobs, and figuring out where is it slow, rather than just doing a short-term fix. And the reason we don't recommend federation is because even though federation itself is stable, what is known as the ViewFS, it's the client table that enables you to view multiple namespaces as one single namespace. That is not stable. There are known issues with that, ranging from everything from hcatalog to Pig to Hive to Impala. All of these components have issues with ViewFS, which means that it'll be hard for you to access your files accordingly. And on to some of the issues I've seen with Yarn, some of the deadly misconfigs I've seen with Yarn. So Yarn can kill tasks that take too much memory. And this is a common issue we've seen, especially when people are trying to optimize their virtual memory. Yarn provides much more finer-grained memory controls, and as a result, there's a lot more to tweak. It also means that once you tweak it correctly, you're going to be less likely to see a lot of scalability issues that MR1 was afflicted with. But at the same time, Yarn is still very much rather a new technology, a new framework. And as a result, what we actually recommend is to disable the virtual memory check for now. Because there are a variety of JVM bugs and OS bugs that can lead JVMs to take up to 100 times as much virtual memory as you have of physical memory. And so in the interim, we're recommending to turn off the virtual memory limits. The application master comes at a default of 1 gig, but because with MR2, you're running just one job within each application master. Generally speaking, your one job is not going to need 1 gig of RAM to run. And so you can size that down, unless you're using an Uber application master, in which case you might need 1 gig to run everything within that JVM. So C groups are by default turned off in the node manager, but if you do need service isolation, if you're trying to run multiple services on your Yarn cluster, so let's say you're trying to run MR2 on your Yarn cluster, you're also trying to run Impala, you're also trying to run Spark, et cetera. You're trying to run all of these different services. You want to segregate the users and the memory resources from each other. And so you would want to turn on C groups. There's a bunch of settings to turn on and to configure appropriately for that. This allows you to control what portion of the cluster is allocated which users and groups, and also controls the resource utilization. So there's no map or reduce concept within Yarn, because all the tasks equal the containers, and it's the application master that actually provides the logical separation when it coordinates the job. So if, for instance, the node manager says it has 16 gigs to use, it's the application master's responsibility to not schedule any reducers until the mappers are done with. And so the benefit of that is you can reach full cluster utilization. For those of you who attended Manek's talk this morning, he showed a graph where with MR2, they were running at nearly 100% cluster utilization, which is something they weren't able to do with MR before. But on the flip side, since Yarn doesn't do any checking to make sure that the configured capacities fit within the physical limits of the machine, your containers could easily end up using more RAM than actually physically exist. And in that case, you'll start seeing swapping out of memory issues, et cetera. So just as we had an info message before for fetch failures, which actually was a lot more of a fatal message, in this case, you've got this error message, which is actually pretty harmless. So we usually do a pretty good job with our error messages, but in this case, this just means that this is just basically telling the affairs scheduler not to log an error for every lookup failure when it can't find a particular job that was probably deleted beforehand. So this is a harmless message. It's fixed upstream. And again, more reason to get your misconfigs right the first time, because when you're looking at these error messages, you can't look at whether it's info, an error, an info, a warning, an error, a fatal, and then figure out the severity based on that. It's often maybe more cause for alarm than it looks to be, or maybe less. And so again, it's better to not have to see these errors to begin with. There are a bunch of great resources online. I've just highlighted a few of them for Yarn resources, especially migrating your workflows, your jobs over. In C5, we have, for MR jobs, we have complete binary compatibility. And we have pretty much 100% source compatibility as well. But for the areas that are not quite compatible, I would recommend checking out these blogs, reading about that in more detail. So misconfigs are something that can quickly creep up on you if you're not monitoring. So we definitely recommend using something, whether it be Cloudera Manager, Embari, Ganglia, Nagios. We definitely recommend using something to consistently and constantly monitor your network. A year ago, I guess more than a year ago, a year and a half ago, when we all had the leap second bug, which no one thought would hit Hadoop clusters, mainly because it turned out to be a JVM issue. Our customers were first alerted to it, and we started seeing 20 P1 support tickets all stream in at the exact same time, because they noticed that they were their activity monitor in Cloudera Manager was suddenly specking 100%. And this was on a Saturday night, so most likely not a lot of jobs were being run, but suddenly everyone's CPU utilization was specking 100%. And so it was that monitoring that they had in place that first alerted them to an issue, which ultimately wasn't a Hadoop issue, but was still affecting Hadoop clusters, since Hadoop clusters all sit on top of the JVM. So we provide tools to help diagnose and understand how Hadoop operates. We also provide training as well. So all of these misconfigs I've talked about, I've fed into the training team, and we've created labs out of these misconfigs. So you can break the cluster yourself, fix it yourself, and there's no better way than to do some hands-on learning as well. Any questions? Yes? So the question was, does Cloudera Manager also track the hardware? Are you talking about issues, errors? Let's see. So to my knowledge, we do track the limits you've set for your operating system. But in terms of errors, so do you mean like if there are kernel errors, is Cloudera Manager going to show that?
Either kernel errors or, let's say, RPs errors. There's some swap messages the RPs can send to the operating system.
If those errors manifest as Hadoop errors, then you'll see them. But CDH and Cloudera Manager, it works on a variety of Linux distributions. And so as a result, it's not able to really be tailored to a particular OS. But often these OS errors, they do manifest eventually further up the stack, in which case CM will spot it. Thank you. See me later for your book. Yes, in the back. Right. So that's a great question. the question was, what about configuration management? Since I had talked about how you tweak something now, and then months later you start seeing errors. How are you going to make that correlation? So it's a really great question. So within Cloudera Manager, it will not just tell you, we recommend that you set, for instance, you set the child heap size to a certain value. We'll also prompt you, if you're changing the child heap size, you should also always change the U limit, for instance, and it will actually flag it. So you can run a validation on your configs, on all your config settings, and then Cloudera Manager will point out to you, you might want to look into this. You set this config, but you didn't tweak this other config that's dependent on that. So it'll prompt you, it'll flag it for you. Does that answer your question?
Well, I was more thinking of storing in time what you did a month ago, this time with some comments, so you find back what you actually changed and why.
I see. So what I've seen is I've seen customers just make comments in their config files in their core site. I've seen actually customers say, we changed this value to blah 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 because of Cloudera support ticket 1234, and so that's something I've seen as a best practice. I thought I saw a hand. Was it you? Yes.
Yeah, sorry. You mentioned that Impala was running on Yarn. Is it new? In my latest updates, it was not running on Yarn.
So Impala, it can in C5. It has the ability, and this is like very latest news, right? I think C5 just came out yesterday, so that's probably why you haven't been updated on it. But yeah, starting in C5, Impala can run on Yarn. Any other questions?
I'm just an engineer at Cloudera. I'm going to use a little bit more detail I can give. You actually do version controls on all the configurations in CM. So if you change something, you can see when and who changed it. So there is a history of that. And I think for the hardware question, there's monitoring for basic IOPS and some of these other kinds of things. Some basic OS things that are generic across all releases that we watch and gather from.
Yeah. Thanks, John. Anything else? Well, I'm up here. If any of you have any further questions, happy to chat one-on-one as well. Thank you so much.